Hi, so in this video, I am going to go through um, ionic bonds and metallic bonds and how we form each, how they compare to each other, and then when we have more than one of each of those bonds, how they're going to interact together. So first, I'm going to talk about forming an ionic bond. So when we're forming an ionic bond, we're going to start with our two neutral atoms. So here I've got a neutral atom of sodium. And remember, sodium, when it's neutral, has that one valence electron, and it would really like to get rid of this one valence electron because the shell underneath is full. And if it could just get rid of this one electron, then it would have a full valence and it would be much happier, much more stable. And then we've got our neutral chlorine atom. And remember, a neutral chlorine atom has 7 valence electrons, but it really wants that full shell, and it would be really happy if it could just get that one more electron to have that full valence. So what happens is sodium's going to give away this electron, which remember carries a negative charge, to chlorine. And when it gives that electron away, that negative charge is going to get transferred to chlorine because now it's got more electrons than protons because it has an extra one. And then sodium now has more protons than electrons because it gave one away, and so it ends up with a positive charge. And then my positive sodium and my negative chlorine are attracted to each other, and they're going to hang out together, forming a bond. So in reality, though, we're never just going to have one sodium ion and one chloride ion. There's going to be lots of sodium ions and lots of chloride ions, and they're all going to be hanging out together. And so what actually happens is we have this one bond between sodium and chloride, but then we also have all these other ions. And so this other sodium ion is now attracted to this negative charge that's hanging out on the chloride. So it's going to go here. But now we have an excess of positive charge that needs to be balanced out. And so this other chloride ion is now attracted to both of those positives. And then similarly, now I've got this positive attracted to this negative, and then this positive can be attracted to this negative, and now I have this excess positive buildup, so this negative is attracted to these positives, and so on. So in reality, when we have all of these ions sitting together, they form what's called a crystal lattice. And in doing that, they can form crystal structures. So that's why when you look at salt, if you look really, really, really closely at salt, you'll see that it actually looks like a square. And if you look even closer, you'll see, or more a cube. So you'll see those crystal structures. And this is just table salt, and that's why it forms those crystal structures. And that's going to be true for any of our ionic compounds. All right, in comparison, if we have a sodium atom, now remember we've got our valence electron because we've got a neutral sodium atom here, not an ion. And really, sodium doesn't want this electron, but if we don't have that compatible nonmetal like chloride or chlorine, then we're going to get stuck with this atom that really doesn't want its electron. What really it wants is to be an ion and then have this electron go off and do something else. But we can't do that because this is attached unless it can go off to another atom. So instead, what happens when we have a bunch of sodium atoms is that we'll have all of these, just their nuclei and their inner shells will all kind of come together, and then they'll all have, they each have one valence electron. So let me pull these over. So we'll have all of these sodium atoms, and then they each have these electrons, and instead of those electrons, I'll send these all to the back. So instead of these electrons kind of staying attached to their one atom that they're on, sorry, give me one sec. Bring all of these to the front. So instead of staying attached to their one sodium atom, they're going to kind of float around and hang out with each other. So that what ends up happening is we get this electron cloud, this cloud of negative charge surrounding this inner positively charged bond between these metal atoms. or rather metal ions, because they have the electrons floating around them. So they're not losing their electrons, but their electrons are just hanging out around this positive charge because they're more stable without them hanging out right next to them. So they kind of float around outside of those atoms themselves, and that's our metallic bond. So what I'd like you to notice is they're similar in that they both have differently charged particles as the bond, but when we're looking at ions, an ionic bond, we have an ion of each element that has its own charge that then comes together to form a bond. But we have these charges, those electrons aren't free floating though. The electrons are firmly hanging out with the chlorine. They're not hanging out with the sodium. But we do have these charges that we can think about. So we're still going to be able to conduct electricity, and we'll see that a little bit more shortly, because we have those charges that electric energy can flow through. With metals, it's just the same element, and rather than these electrons being attached to one specific ion, they're floating around on the outside, kind of forming a cloud around. So these electrons are free flowing and they have all the negative charge. But if I was to have an electrical current go through here, it could still flow through because I've got charges